Hey, what's up guys? This video is for section 9.1, graphing quadratic functions in standard form, but this is part 2. So keep in mind that in standard form is when the function looks in this form, this way right here, f of x equals ax squared plus bx plus c. So we are going to have some numbers for the a, the b, and the c. They're going to be negative, positive, they can be fractions, or just regular integers. But I'm going to give you guys some steps to follow to graph those parabolas, which are quadratic functions, and we are going to have to find a few components, the vertex and the axis of symmetry, the y-intercept, to graph the parabola. So here are a few steps you can follow to graph that quadratic function. So let's look at step number 1. So when you guys have standard form, f of x equals ax squared plus bx plus c, keep in mind that a cannot equal to 0. You always have to have something for the a 1, a negative 1, or a 5, or a 7 with an x squared. First step is to find the vertex. Now, the vertex will be the minimum point or the maximum point of the parabola. We need a coordinate for the x and the coordinate for the y. So we need the x and the y. We are going to use a formula to find the x value. So the x value for that vertex is going to be negative b, opposite of b, divided by 2a. So keep in mind there's the a with the x squared, the b is the one with the x. You guys are going to substitute and you simplify. After you guys find the x, you are going to substitute that x value into the function. So you're going to go back to the x, you're going to go back to the x, you substitute, and you simplify, and you find the y value. So you get the x and the y. If the question asks for the minimum or maximum value, well, keep in mind that the y value of that vertex is your min or max value. Step number 2, you need to draw your axis of symmetry through the vertex, a vertical dashed line that will cut the parabola in half. If they ask for the equation of the axis of symmetry, and guess what? I will ask for that equation of the axis of symmetry. Well, it's going to be x equals negative b over 2a, opposite of b divided by 2a. Now, guess what, guys? Up here, x equals opposite of b over 2a is for your vertex. So once you find the vertex, you actually already found the axis of symmetry. The equation of the axis of symmetry is the same x as the vertex. Step number 3, after you guys have your vertex and your axis of symmetry, you are going to find the y-intercept, and you're going to graph it. The y-intercept is going to be 0. You're going to let x equal to 0. That's the y-intercept, comma, the c value. So all you do, guys, you look up here for the c value, and that's going to be your y-intercept. After you guys have your y-intercept, we are going to use a pattern 1, 1, 2, 4 that I kind of talked about in my last video from the vertex, and reflect to make more points and to reflect the points on the other side of the axis of symmetry, and then you draw your parabola. So let's go ahead and try and graph this function here. We're also going to learn and practice how to state the domain and the range for the parabola. But first, we need to graph it. So my function is f of x equals x squared minus 5. It is a parabola because the x has a square. The highest exponent in this function is 2. So it is a quadratic, and the quadratic will be a parabola, a U-shape. A couple things you guys can see right away is the a value right here. So I'm just going to label that for you guys. My a value is the one with the x squared. The b value is the one with the x, but guess what? We don't have a regular x in the middle, so there's no b, but we do have a constant. So the minus 5 will be your c value. So we have the a, and let me just put an invisible 1 here. We have the c, the constants, and we are missing the b. When that happens, when we don't have b, well, we're just going to let b, or set b equal to 0 because we are missing that b. So to graph it, step number 1, we need to find the vertex. My vertex, we need the x value and the y value. So to find the x value, we have a formula, opposite of b divided by 2 times a. So I'm just going to substitute what I know. Opposite of b, remember we don't have b in this function, so we say b equals 0. So I'm going to put negative 0 0 is not negative or positive, so don't worry about the sign. And on the bottom, you have 2 times a, and your a value is 1. So you substitute a 1. So you simplify this here, 0 over 2. You guys multiply the bottom, x equals 0. So I know what the x value is for my vertex. X equals 0. But now I need to find the y. So remember that f of x is the same thing as y. So I'm going to bring this down, but I'm going to change it to y because I'm actually looking for the y value for the vertex. And I'm going to substitute my x value 0 into the function. And we only have one x here. So I'm going to put 0 squared minus 5. Remember that the 1, invisible 1, you don't need it in front of the x squared. So you just put parentheses 0 squared. You guys simplify that. So y equals negative 5. So my y value for the vertex is negative 5. Let's go ahead and plot it. I'm going to graph the point 0, negative 5. So 0, negative 5 is right here on the graph. And I know that is my vertex. So let me put V for vertex. And we know we can find out what is the direction of the parabola just by looking at the a value. So looking at the a value, positive 1, the parabola is going up because we have a positive a. So my U shape has to go up, regular U going up. Now you're not going to make a random parabola, a random U shape, because we need more points to actually be a little bit more accurate. So my second step is to draw the axis symmetry, and then I'm going to find a couple more points. So my axis symmetry is through the vertex, and it is on top of the y-axis. So I'm going to make a vertical dashed line right here through the vertex, and it's actually, the dashed line is on top of the y-axis. So we have the axis of symmetry. Now my equation, so let me put step 2, axis of symmetry. My equation of the axis of symmetry is the same x value as your vertex. So you look at the vertex up here, and x equals 0. We actually have it here. So my equation of the axis of symmetry, x equals 0. Now we can go to step number 3. Step 3, we need to find the y-intercept, int for intercept. So remember that for the y-intercept, we let x equal to 0. So we put 0 right there. And my c value is negative 5. So my y-intercept is going to be at 0 and your c value. So we do have a minus 5. Negative 5 is here. So my y-intercept is 0, 1, 2, 3, 4, 5. Oh, guess what? The vertex for this graph is the y-intercept. That can happen. It doesn't have to happen every time. The y-intercept can be different than the vertex, but right now they're the same points. So in step number 3, we are going to use a pattern to find a couple more points. So the pattern is 1, 1, 2, 4. So you guys are going to make like a little cross, and I want you guys to do this on your paper. You're going to put a 1, 1, and 2, 4. So what that means, guys, from the vertex, you are going to move. So here's the vertex. You're going to move 1 to the right and 1 up. So 1 to the right and 1 up from the vertex. Don't go back to the origin. You guys go to the vertex. So when I go from the vertex, 1 to the right, 1 up, I'm going to make a point right here. And then I go 2 to the right from the vertex and 4 up. So from the vertex, 1, 2, 1, 2, 3, 4. And I make a point right there. And you guys are going to reflect the points on the other side. Now remember, we talk about symmetrical. It is symmetric, so the left side equals the right side. So if this point here is 1 step away from the axis of symmetry, then on the other side, 1 step away from the axis of symmetry, you have the other point. You reflect. That's what we say. The axis of symmetry is like a mirror. So you have a reflection. And the other point here, this one is 2 steps away from, or 2 units away from the axis of symmetry. So on the other side, from the axis of symmetry, 1, 2, you guys will make another point right here. And notice that they are at the same height, those two reflections, same height, those two reflections. And you guys are ready to draw your parabola. So now you guys are going to connect the points. You're going to make a U shape, and it's going to go up like this. Your arms, make sure that they are going up. Let me make it a little bit darker so you guys can see the actual parabola. So it is a U shape. The parabola is going to infinity, up, 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 up. But that's enough. That's okay if you guys have those arms. That's what I say. I call this the arms of the parabola. They're going up. So we got the parabola. The shape is a U shape. It's a parabola. We got the vertex right here. The vertex is the same as the y-intercept, and we have the axis of symmetry. Now, for the domain and range. Domain in a parabola are the x values. Domain are the x values. So we want to know what numbers actually work in that function. So in every parabola, any x value will work for that function. So for your domain, you guys are going to write domain all real numbers. Now there's a symbol that we guys can use, numbers here, which is kind of like an R. You make two vertical lines parallel, and then you start making an R. This symbol means all real numbers. Can you guys use the symbol in my class? Yes, you can. I know that's all real numbers, so that is my domain. My range, it depends on the vertex. So let's talk about the range. Now the range are the y values. And let me write down the range here. So we want to know range, y values. What are the y values that work for that function? So if you pay attention to that parabola, to the actual shape, the vertex is at -5 on the y-axis. So the y values are in the same direction as the parabola. So the parabola is going up from the vertex. So when it's going up from the vertex, what it means is the y values have to be greater than the -5 in the vertex. So y values are greater than 5. Now the vertex goes through the -5. So the y values have to be greater than or equal to -5. So that's what it means. When the parabola is going up, we use a greater than for our range. So I'm going to put y is greater than or equal to -5. Now once again, the -5 comes from the vertex. That's your y value, and the parabola is going up. So the parabola is on top. You can say it goes up the vertex. If the parabola is going down, well, guess what, guys? This inequality is going to change. If the parabola is going down, you guys are going to use a less than or equal to. And I do have an example where that happens, but this is what you guys need to know about parabolas. You need the vertex, you need the axis of symmetry, we need the y-intercept. We are going to use that pattern 1, 1, 2, 4. And if you guys don't, I'm not sure where that pattern comes from, you can watch my first video. I talk about the parent function and a t-table, so you guys will see that pattern in the t-table. And for the domain, we have all real numbers, which are the x values, and the range are the y values, and the y values can be greater than or less than where the vertex is at. It's all about the vertex. So let's try another example. So this one here, we have f of x equals -x squared minus 3. So first of all, we need to know what is the a value and the b value and the c value. So a is the one with the x squared. So here's the a. B is the one with the x. Well, guess what, guys? There's no b, but we do have a constant. C is your -3. So let me just put here b equals 0, so I don't forget, because we don't have 1. There's no x term in the middle. We have an x squared, but not the x. And this is from the standard form in your quadratic trinomial. So after you know what's a, b, and c, let's go ahead and find what the vertex is. And for step number 1, we are going to use a formula to find the vertex. So here's the v for the vertex, and I'm just going to put an x on the top and a y. That's what we're looking for. For the x value in the vertex, the formula to find that value is negative b over 2a, or opposite of b divided by 2a. You guys are going to substitute the values. So the opposite of b is 0. We have b2 equal to 0 here. So I'm just going to put a 0 on the top, and on the bottom we're going to multiply 2 times a negative 1, which is your a value right here in front of the x squared. So when you guys simplify that fraction, we get x equal to 0. So we put a 0 here, and then you guys will go back and going to substitute the x value into the function, and then you're going to find the y. Remember that this notation here, f of x, is the same thing as y. So I'm going to change that y equals negative, and I'm going to substitute the 0 inside of the parentheses, square minus 3. And that 0 is from the x. Let me just put a box here so you remember your x value is 0. So when you guys substitute this right here, it equals to negative 3. So our vertex is at 0 and negative 3. Let's go ahead and plot that point on your coordinate plane. So 0 and negative 3 is going to be right here. Step number 2, you guys are going to look for your axis of symmetry. So step 2 here, we have axis of symmetry. And you guys are going to draw that vertical dashed line through the vertex. So we know the vertex is right here, the one we plotted. So my dashed line is going to go through that point, vertical, and it's going to cut the parabola in half. And this is what helps us to copy, reflect the points on the other side after we find 2 points on one side of the parabola. So the equation though of the axis of symmetry will be x equals your x value in your vertex. So the x coordinate is the same one, same equation for the axis of symmetry. So we put 0. Step number 3, I'm going to find my y-intercept, and my y-intercept, remember that we start with the 0, that's your x value, 0, and then your c value in that function up here, c is going to be your y-intercept. So negative 3. I'm going to plot that point so I don't forget the y-intercept. And 0, negative 3, well, guess what, guys? It's the same thing as the vertex. So the vertex in this case it works like the y-intercept. But I do need a pattern so I can find 2 more points. And I'm going to make my cross here, 1, 1, 2, 4. That's the pattern that we use when you guys plot a parabola. You have to be careful though, because your a value up here, a value is negative 1. What that means is you're going to have to multiply this 1 by negative 1, which equals negative 1, and the 4 by negative 1, which equals negative 4. Every time you guys have that a value not equal to positive 1, you have to multiply these 2 numbers by that a value, because the a changes the width of the parabola. So we need to find the new points. So from your vertex, you're going to go 1 step to the right and 1 step down. And that's what the negative means here. You go down. So 1 to the right. And I'm just going to show you guys from the vertex. 1 to the right, 1 down. And you guys make a point here. And then from the vertex again, 2 steps to the right and 4 down. So 1, 2, 1, 2, 3, and 4 down. So we have our point right here. Now those points you are going to reflect on the other side of the axis of symmetry. So the axis of symmetry is the dashed line. This point is 2 units away from the axis of symmetry. So on the other side, you're going to copy, you're going to reflect 1, 2 steps away from the axis of symmetry. So you're going to make a point here. And this one is 1 unit away or 1 step away. So on the other side, it's going to be 1 step away or 1 unit away from the axis of symmetry. And then you guys will make your parabola, connect the points. It is a U shape, so you make a U going down, and we got the graph. But now the next question says, well, we want to find the domain and the range. So domain, remember those are your x values. What are the x values in this function? So my domain, and this is for any parabola, is going to be all real numbers. And remember that we do have a symbol or a notation for all real numbers, which is looks like an R. We have 2 vertical lines, and you make an R like this. for representing that it's all real numbers. Your range, that changes depending on the vertex. Your range are your y values. I want to know what are the y values for this function. Well, let's make sense of the problem. First of all, I'm going to start with the y here, and I'm going to go to the vertex right here, and I notice that the parabola goes under the vertex. So the y values, if you look at the y-axis, are going down, which means they're getting smaller and smaller and smaller and smaller. So we say that the range will be y is less than or equal to, and we need the y for the vertex, which is -3, which is the coordinate, the y coordinate, and it's -3. So what this is saying, guys, your y values in this function, which is the parabola, the y values are less than or equal to -3. Less than because it goes down from the vertex, the parabola goes down, that's why we use a less than, and it's or equal to because it actually, the parabola actually crosses that point at -3. Okay, so let's do a little bit more examples here just to have more practice. And I do have the function y equals 2x squared minus 4x minus 6. Notice they're not using the y of x, or not y of x, f of x at the beginning of the function. They do have a y, so that's the same thing, but I'm going to follow the same steps. So I need my a value, and my a value will be 2, that's the one in front of the x squared, right here. And then I need my b value, which is -4, and my c value, which is -6. So in this function, we do have all three variables, the a, the b, and the c. And just to make sure, once again, a is the one with the x squared, the coefficient, b is the one with the x, coefficient, -4, and c is your constant. So step number 1, you guys are going to find your vertex. And to find your vertex, we use x equals -b over 2a. And remember that we're looking for the x value and the y value here. So I'm going to substitute the x, the b and the a to find the x. So opposite of b right now is -4. So the opposite is +4. That's what the negative says right here. -b means the opposite of b. Divided by 2 times your a value, which is 2. You guys are going to simplify that x, and your answer will be 1. 4 divided by 2 times 2 equals 1. So now I'm going to go back and I'm going to substitute this number 1 into the function right here. So remember that we are substituting the 1 into the x. So y equals, and you substitute the 1 into the x right there, -4 times 1 minus 6. So your y value is going to equal -8. Okay, guys, so notice we have the a, we have the b, and we have the c. So the vertex is not on the y-axis this time because there's a b value. So with the b value, we have the vertex at 1, -8. So you guys are going to plot that point, the vertex, at 1. So from the origin, you go 1 to the right. And then you guys go down 8. 1, 2, 3, 4, 5, 6, 7, 8, which is right here. And we have the vertex. Now looking at the a value, and I'm just going to show you guys the a value again, it is +2. So that means the parabola is going to go up. And that's what it is when a is positive, it goes up. So my vertex, I'm going to label the vertex right here. Step number 2, I'm going to draw my axis of symmetry. And my axis of symmetry is at the vertex. So I make a dash line. So dash through the vertex. And notice once again, it's not on top of the y-axis because my vertex is at 1, -8. So I do have my axis of symmetry. And my equation of the axis of symmetry is your x as the vertex, in the vertex. So x equals 1. And I'm going to put a 1 right here. So third step, I need to find my y-intercept. So my y-intercept will be my 0 for the x and my c value for the y coordinate. And the c value, let's go back here, -6. So my y-intercept is at 0 and -6. And I'm just going to plot that point. 0, -6 is right here. And I have the y-intercept. Let me just label that for you guys so you remember that's the y-intercept. Now we need the actual pattern. So for my pattern, I have 1, 1, 2, 4, and I make a cross just to set up my numbers 1, 1, 2, 4. My a value, notice it's not 1, so I'm going to multiply this number by 2, which is the a value, which equals 2, and the 4 by 2, which is the a value, which is 8. So I'm going to plot those points from the vertex, not from the origin. This pattern, you have to use it from the vertex. So from the vertex, I go 1 to the right and 2 up. So I make a point right here. And if you guys notice, pay attention, that point on the other side is your reflection of this point on this side. So we already got a reflection here. The y-intercept works as a reflection. But now I need to find my second point. So 2 to the right from the vertex, 8 up. So from the vertex, 2 to the right, 1, 2, 3, 4, 5, 6, 7, 8. And I make a point right here. And once again, guys, my point is 2 units away. So on the other side is 2 units away. So it's right here. And I make my U shape. And it's going up. When I connect the points, it is going up. That's because the a value is positive. If the a value is negative, then it's going to go down. So now you guys are going to find the domain and the range. So my domain, remember, that's going to be all real numbers for any parabola. Any x value will work in this function, but not every y value works because your range is going to be your y values, and my y values will start at the vertex. So R for range, and my vertex is here, so the parabola is going up from the vertex. So what that means is we have to use a y is greater than or equal to, and the y value of the vertex is -8. So we put a -8 right there. So the numbers that work for this function, for the y, the range, will be greater than or equal to -8.